तुमची आवडती भाजी.
Welcome to the complete Unified Modeling Language course. In this course, you will gain the knowledge and skills needed to master UML, from the basics to the most advanced concepts. By the end of this course, you will have the confidence to design UML diagram like a pro. If you are searching for a comprehensive, easy to follow, well organized and practical course that takes you from zero to hero, then you have come to the right place. You don't need any prior knowledge of UML. Everything you need to know is all in one place. No more jumping back and forth between random tutorials. Everything is right here for you. My name is Yogesh and I am a software developer with over a decade of experience working in IT industry. I have taught thousands of students about software development and now I am here to help you to become a UML expert. If you follow along with me in this course, then it is my promise to you that at the end of this course, you will become the master of UML diagrams. You will have a thorough understanding of 14 different types of UML diagram, why to use it, when to use particular diagram, how to use it effectively and efficiently. You will have a brief understanding of what mistakes people usually do during designing this diagram and what are the best practices to follow when using UML in a software project. At the end of this course, if you think you realize the benefit which are promised, then it's my humble request to you to leave your valuable feedback in the comment section. And don't forget to rate this course so that the future student will able to distinguish the best from the averages. I am excited to take you through this course. So let's dive in and get started on your journey to becoming a UML master. Welcome to the exciting course on the Unified Modeling Language, that is UML. In this course, I have carefully structured the content to ensure that you get the most out of it. First, we will start by understanding the why behind learning UML and problems it solves. Then we will dive into a brief overview of what UML is and the different types of UML diagrams that exist. But that's not all. We will also introduce you to some of the best UML designing tools out there so you can get started right away. The real fun begins as we delve deeper into each UML diagram and break down its essential building blocks. We will then use a relatable case study and online shopping application to walk you through the process of creating a real-life UML diagrams. But we don't stop there as well. We will also cover the common mistakes people make when designing a UML diagram and teach you the best practices for designing and managing them effectively. And last but not the least, we will show you how to stay ahead of the curve and up to date with the latest advancement in UML. All the relevant course material you can find attached to the lectures. By the end of this course, you will have everything you need to work effectively and efficiently with UML in any IT software project. Get ready for an exciting journey of discovering and learning UML. Have you ever faced any of these problems while working in a software project? The first problem is you are a software developer working on a complex project with other fellow developers. Now you need to communicate with each other about how your parts of project will work together. Now you are communicating in plain language, but the fellow developers asking you lot many questions that you have already answered and you are getting frustrated. You are spending hours in meeting going back and forth trying to clarify your ideas. You realized it is a waste of time and resources. What if there was a way to visually model your design and communicate them more effectively? It will be great, right? Here UML comes in. One more problem is, we all know that every software project will have different people with several roles like product owner, business analyst, solution architect, developers, and so on. If you see, when it comes to software design and development activities, everybody communicate in different language. Developer will communicate in coding terms, product owner will communicate in functional or business terms, architect will speak about the overall project level, and so on. So challenge is how to make them communicate and collaborate in a single unified language. Here again UML helps. Third problem is, imagine you are a developer recently joined a new project. You are trying to understand the code base. There are hundreds of coding files, each having thousands of line items. You are scratching your head to figure out how the code is interrelated and its flow of working. Is there any simpler way to understand all this quickly? Then UML is the answer. Fourth problem is, you are a product owner with a lot of requirements in mind. You can document them in plain language, but you are not able to visualize the structure, flow, and behavior of the system easily. When you visualize the structure, you forget the flow and vice versa. This is the problem UML helps to solve. And the next problem is, have you ever faced this? You develop and code the application, and at the last, you will get the opinion and views of your colleagues, and they said that you have developed something else than expected. then you end up with a big frustration because you spend hours in developing and coding that part. But what if, before developing or coding actual part, you can get the views and opinions of your colleagues on the final output structure or design? That will be awesome, right? And UML helps to make it possible. All these problems will be easily handled with UML. UML stands for Unified Modeling Language. It is a visual modeling language that allows us to create diagrams to represent the different components of the system and how they interact with each other. UML diagrams are easy to understand and they help us to communicate ideas and concepts to other stakeholders in a clear and concise way. And remember the quote, the picture is worth 1,000 words. For example, for our first case, component diagram can be used to show how the part of software works together. For our third case, a simple UML class diagram will visualize you how the classes in our code related to each other and how they have structure and what is the flow of the code. And for the fourth case, a simple structural and behavioral UML diagram can help product owner to demonstrate the structure, flow, and behavior of the system. So you can see how the big problem will be simply solved using the simple UML diagram. Hence, if you would have noticed this, UML is a part of engineering curriculum. It is expected that everybody who is related to computer or IT and working in software projects should able to understand the UML diagrams. This much important UML is. Lack of UML knowledge will limit your ability to contribute effectively to the software project. In conclusion, UML is an essential tool for any software development project. It helps us to create a clear and concise system design, which can save time and money and prevent project delays and cost overruns. So the next time you are working on a software project, remember the pain points of not using UML and consider using UML to create a better system design. Now it's the time to understand what is UML. Let me make it clear to you that it is not a programming language because many people look at the term language in it and they think it can be just similar to the other programming languages like C#, Java, JavaScript, but it's not. It is a pure modeling language. Now let us understand what is modeling language. For this, let us first understand what is model. So model, you can say, is a final version of a product which is made prior to the actual work getting started, right? Models are often built in order to better understand the existing or future systems. To give you an analogy, have you ever watched a building being constructed? Before the construction starts or the workers start building, the civil engineer first creates a model of the building. That is a blueprint of the building, like a demo 3D model, floor plans, exterior views from the different sites, etc. The same is true for software development. The model of a project is created well before the actual execution of the project, and that is where UML comes in. Now focus on the word unified. Now every software project will have a different stakeholders like developers, designers, testers, project managers, business analysts, architect, product owner, project managers, everyone with a different technical background. So if solution architect communicate in more technical terms, then might be few members in the team will not able to understand it. But by using UML to communicate, you are creating a common language that everyone on your team can understand regardless of their technical background. Till now, if this is very clear to you, then let us now define UML. UML stands for Unified Modeling Language, which is a standardized visual modeling language used for designing software systems. UML is a language that is used to create a visual representations of the software system, which can help business analysts, software developers, designers, and architects to better understand and communicate the design and structure of the software system. You can also say it is a blueprint of your project. UML includes a set of diagrams such as use case diagram, class diagram, sequence diagram, activity diagram, and other that are used to model different aspects of software system. These diagrams can be used to illustrate the system functionality, architecture, and behavior, and can help to identify potential problems or inconsistencies in the design early in the development phase. UML is widely used in software engineering and is considered to be an industry standard for visual modeling. It was developed by a group of software industry experts in the 1990s and has since been maintained and updated by the Object Management Group, that is OMG, as an international organization responsible for developing and promoting standards for software and other technology. OMG specification mention on their official website about UML as the Unified Modeling Language is a graphical language for visualizing, specifying, constructing, and documenting the artifact of a software-intensive system. And for your information, the latest version of UML present in the market is UML 2.5.1, and it has around 14 different types of diagrams with different purposes. So this is all about what is UML. Welcome to the fascinating world of UML diagrams. UML is a modeling language that uses various views to represent the blueprint of a final project from different angles. Just like every picture tells us a story, every UML diagram carries a special purpose, meaning, and representation. The latest version of UML as of today is UML 2.5, which has a total of 14 different types of diagram. These diagrams are divided into two main categories: structural diagram and behavioral diagram. Let us see first the structural diagram. These diagrams represent the static aspect of the system and emphasizes the things must be present in the system being modeled. Since this diagram represent the structure, they are used frequently in documenting the software architecture of the software system. Diagrams which are in this category are: first, class diagram. The class diagram describes the classes of application being modeled along with their relationship to one another. Class diagram represent the blueprint of the code. It is a very near view of the code of a system. If you see the class diagram, you will get all the idea of how your code will be structured and how it will be working. Next diagram is object diagram. Object diagram gives us the snapshot of the detailed state of a system during a point in time. If you see the object diagram, you will get idea at the given moment which all objects are active and how they are related. Next diagram is component diagram. Component diagram visualizes the implementation view of the system, means it represents the high level view of the system. If you see component diagram, you will get to know all the components of your project. Next diagram is composite structure diagram. This diagram is used to describe the internal structure of a class or a component or a part of the system. This diagram gives the microscopic view of the class, component or part of the system. If you see the composite structure diagram, you will get idea how the particular part of the system work internally. Next diagram is deployment diagram. Deployment diagram is used to describe the physical deployment of a system, showing the hardware and software components and how they are deployed across nodes. If you see the deployment diagram, you will get to know how your application is deployed all together. Next is package diagram. Package diagram used to organize and show the dependency between various packages or modules in a system. If you see the package diagram, you will get the idea of how your application code is packaged or bundled together. And the final diagram in this category is profile diagram. A profile diagram is a type of UML diagram used to represent the different types of profiles. It shows the stereotypes, tag values, and constraint of the profile. If you see the profile diagram, you will get to know what are the extended capabilities of your application. Now coming to second category of UML diagram, that is behavioral diagram. The behavioral diagram shows how the system works in motion. That is how the system interacts with external entities and users, how it responds to input or events, and what constraint it operates under. Since these diagrams explain about the behavior of the system, they used extensively to describe the functionality of a software system. Diagrams that are in this category are: first, use case diagram. Use case diagram is used to describe the behavior of a system from user's perspective, showing the various use cases and actors involved in the system. If you see the use case diagram, you will get to know the full functionality of the application. Second kind of diagram is activity diagram. Activity diagram is used to describe the behavior of a system as a sequence of activities, showing the flow of control from one activity to another. The next type of diagram is state machine diagram. State machine diagram used to describe the behavior of an object or system as a set of states and transitions between them. And the next kind of diagrams are interaction diagrams. Interaction diagrams is a type of UML diagram that is used to capture the interactive behavior of a system. Now, this is a sub kind of diagram. Inside interaction diagram, there are few more diagrams. Those are sequence diagram. Sequence diagram used to describe the interaction between the objects in a system over time, showing the sequence of messages exchanged between them. Next type of diagram is communication diagram. Communication diagram used to show the interaction between objects or parts of the system, emphasizing the messages exchanged between them. Then timing diagram. Timing diagram used to describe the timing constraint between objects or parts of the system, showing the relative timing of events and messages exchanged. And the final interaction diagram is interaction overview diagram. Interaction overview diagram is used to describe the flow of control between different parts of the system, showing the interactions and decision points between them. This is in short about all the 14 different UML diagrams. Each diagram is like a chapter in a story, and together they create a complete picture of a system you are building. And in the upcoming session, we will dive into each one of these diagrams, exploring their essential building blocks and sharing a real life example or case studies of each one. So get ready for an exciting journey through the world of UML diagram. It's going to be a wild ride. Are you tired of drawing UML diagrams by hand? Do you want to create a beautiful and professional diagrams quickly and efficiently? Then look no further. In this session, we will explore some of the top 5 UML tools that can help you to draw different UML diagrams with ease. First one in our list is Star UML. Star UML is a tool specifically used for drawing UML diagrams. It is a diagramming tool mainly used for agile and concise modeling. Star UML is available only as a software, so it requires system storage and system compatibility to download the software. It is available on the platforms like macOS, Windows, and Ubuntu. This is one of the good tools available in the market. Just download and install and you are ready. It is a free for drawing the UML diagram, but they might ask you to pay if you want to use some advanced feature like download and export the diagrams. In free version, you can download and export, but those comes with the watermark of star UML. But I feel for learning purpose, this is one of the best tool to get started with. Next tool is about draw.io. Draw.io is a free open source collaborative workspace for drawing UML diagrams. It also contains predefined templates for drawing UML diagrams, creating wireframes, business charts, etc. It is available as both software and online tool. It is linked with Google Drive, so it automatically saves your work over Google Drive. It is a free tool available. This is also one of the good tools to start with. As per my experience with this tool, it has some basic UML shapes and components. Some of the shapes are missing in this, but this is also one of the good tools to start with. Next is Plant UML. Plant UML is a free tool that allows user to create UML diagrams using a simple text-based syntax. So remember this, it creates a UML diagram based on the text. I didn't saw direct drag and drop features here. You need to write a syntax and accordingly it will create a diagram. This tool is a great option for developers and technical writers who needs to create a UML diagram quickly and efficiently. It is a free tool available in the market. Next tool is Lucidchart. This is a paid online UML tool which you can use to draw the UML diagram. One good thing about this tool is it provides you the ready-made template for the UML diagrams. You can just edit those and get started with your diagram. Next tool is Visual Paradigm. Visual Paradigm is a software tool that business organizations use for planning and modeling. It is available both as an online tool and as a downloadable software. User can sign up for the online tool with a single account. The tool comes with a predefined layouts to help user get started quickly. Visual Paradigm is a paid platform, but it offers a free trial of 30 days for user to try it out before committing to a subscription. So this is all about the top 5 UML tools available in the market. In conclusion, there are many tools available. You should use the one which suits your needs the best. In this course, we will be using Star UML, a free and easy to use tool that's perfect for beginners. You don't need to pay at all and all the features which are required are available in free in Star UML version. Today, we are delving into the fascinating world of UML diagrams, specifically starting from the almighty class diagram. This diagram offers the bird's eye view of the structural and static component of the entire system. The class diagram describes the classes of applications being modeled along with their relationship to one another. Class diagram represents the blueprint of the code. It is very near view of the code of the system. Now I know what you are thinking. What's the big deal? Well, let me tell you. The class diagram is a powerful tool that can help you gain a comprehensive understanding of your application's inner workings. Whether you are focused on a specific subset of a classes or an entire shebang, the class diagram has got you covered. Now let us learn the fundamental concepts of class diagram. So let us start with classes. Classes are the building blocks of the class diagram. They represent the objects or entities in the system and define their attributes and behaviors. You can identify a class by a box of 3 compartments. One note is classes also refer as entities in software lingo. Here you can see a sample visual notation of an employee class along with the employee class code. The first compartment will hold the class name. Now let us move to attributes. Think of attributes as the properties or characteristics of a class. For instance, here employee class may have attributes like first name, last name, email, etc. These attributes are represented in the second compartment of the class box. Now let us move to the next concept of a class called methods. Methods are an action that a class can perform, such as calculating a value or updating an attribute. You can find them represented in the third compartment of a class box. For instance, calculate salary, get address, these are the methods of an employee class. Now the next concept is about visibility. Every class member, attributes and methods has a specific visibility assigned to it. To represent them in UML, the below notations will be used. Public attributes and methods are represented with the plus sign and they are accessible anywhere in the program and may be called by any object within the system. Then private. Private attributes and methods are represented with minus or negative sign and those are accessible in the class that defines it. Then next one is protected. Protected attributes and methods are represented with the hash symbol and they are accessible in the class that defines it and a subclass of that class. Then next is package. Package level attributes and methods are represented with the tilde symbol and these members are accessible in the instances of the other classes within the same package. The next important concept to understand in a class diagram is relationship. Let's take a closer look at the different types of relationship exist in the class diagram. The first one is association. Association shows how objects of one class interacts with the object of another class and define the multiplicity of the relationship. This can be one-to-one, one-to-many, many-to-one or many-to-many relationship. Associations are depicted as a line connecting two class objects with endpoints that can be labeled to show the multiplicity. For example, consider an example of student and course. A student can take multiple courses and a course can be taken by multiple students. So they are bound with the association and this represents a many-to-many relationship. which is shown in the UML diagram like this. The next type of relationship is inheritance relationship. Inheritance represents the hierarchical relationship between classes, where a subclass inherits attributes and methods from its parent's class and may add or override some of its own attributes and behavior. This relationship is represented by an arrow pointing from the subclass to the superclass with a filled triangle at the arrowhead. For example, a dog is a specific form of animal and inherits the characteristics from the animal class. This represents an inheritance relationship, which can be considered in the UML diagram like this. Then the next type of relationship is aggregation relationship. Aggregation is the type of association that represents a whole part relationship between two classes. It indicates that an object of one class contains the object of another class. The part class has its own life cycle and it can exist independently of the whole class. Let me repeat. The part class can exist independently of the whole class. Aggregation can be thought of as a has a or a is part of relationship. For example, wallet and money. A wallet has money, but money doesn't necessarily need to have a wallet, right? So it's a one-directional relationship and money can exist without wallet as well, right? Another example is of car and wheel example. A car cannot move without a wheel, but the wheel can be independently used with the bike, scooter, cycle or many other vehicle. The wheel object can exist without the car object, which proves to be an aggregation relationship. Aggregation relationship is represented in the diagram with the line joining the whole and part class with a hollow diamond pointing to the whole class. Now let us move to the next type of relationship, that is composition type of relationship. Composition is a special type of aggregation that represents a strong whole part relationship between two classes. In a composition relationship, the part class has a much tighter coupling with the whole class and it cannot exist independently of the whole class. Let me repeat. The part class cannot exist independently of the whole class. For example, a human needs heart to live and the heart needs a human body to function. This represents a composition relationship. Both cannot exist independently of each other, so they are tightly coupled. Another similar example is of folder and file. Folder contains the file, but if folder deleted, the file is also deleted. So again, part cannot exist independently of the whole class. Composition relationship is represented with the line joining the whole and part class with a filled diamond pointing to the whole class. The next type of relationship is realization relationship. The realization relationship in UML represents how one element implements the behavior specified by another element. It is commonly used to model the relationship between an interface or an abstract class and its implementations. For instance, a concept of a vehicle is an abstract idea that can be realized in a various forms such as a car, truck, bus or bicycle. These realizations share a common features but have a distinct characteristics and behaviors. In UML, the vehicle concept can be represented as an abstract class or interface, while each specific realization can be modeled as a subclass that implement the abstract class or interface. In an interface, the realization relationship shows how a class that implements the interface provide a concrete implementation for a method defined by the interface. In contrast, in an abstract class, the realization relationship depicts how a subclass provides concrete implementation for the abstract method defined by the abstract class. The realization relationship is symbolized by a dashed line with an unfilled arrowhead pointing from the client element to the supplier element and the keyword realize written near the arrowhead. Now some of you might got a doubt. Is the inheritance and realization looking same? But it's not. Realization models how one element implements the behavior specified by another element, while inheritance models how one element inherits the properties and behavior of the another element. The key difference between implement and inherit is that implementation involves providing concrete implementation for methods defined by an interface or an abstract class, while inheritance involves inheriting properties and behavior from the superclass and possibly adding more to it and overriding them in the subclass. Next important concept which we are going to see is multiplicity in class diagram. Once you have established the type of association relationship by connecting the classes, you can specify the number of instances of one class that are linked with the instance of another class. Multiplicity is often denoted as a range of values such as 0 to 1, 1 to star, 2, 4, which denote the minimum and maximum number of instances of class that can be linked with the instances of another class. There are different types of multiplicity that can be used in the UML association. The first one is 1 to 1. In this type of association, one instance of class is associated with only one instance of another class. The notation used for this type of association is 1 dot dot 1. Next is 1 to many. In this type of association, one instance of a class is associated with multiple instances of another class. The notation used for this type of association is 1 dot dot star. Then many to 1. In this type of association, multiple instances of a class are associated with only one instance of another class. The notation used for this type of association is star dot dot 1. and the final one is many to many. In this type of association, multiple instances of a class are associated with multiple instances of another class. The notation used for this type of association is just star. By understanding the concept of multiplicity, you can represent the relationship between classes more precisely in UML diagram. So this is all about the fundamental basics of class diagram. Welcome to this session of class diagram. In this session, we will see real-life class diagram of online shopping application. Till now, we have learned that class diagram is very close to the code. Hence, it is also referred as a blueprint of the code. It gives us the class-level view of the application and ultimately also gives us the idea on how our code will be structured. Now, let us see the real-life class diagram of online shopping application. So, here is our class diagram. You can see it represents the classes which are involved, relationship between the classes, then the class attributes, operations or methods, their visibility, multiplicity, and everything about the class diagram. Let us see all these components one by one. Let us start with the order class. You can see the attributes marked with the visibility, either public, private, protected, or packaged. Here for simplicity, I have made them private for all, but you can mark as per your requirement. Then you can see the operations. Again, operations are marked with the visibility as public by default, but you can change as per the requirements. Then you can see the return types present in front of each operation. This is about the order class structure. Now let us see the relationships of order class. Now every order contains the product, right? So if I ask you, can product class live without order class? Then the answer is yes, right? It's possible. Now if I ask you, can order class live without a product class? Then you will say, boss, this is not possible because every order can only be called as order if it has a product. So order won't exist without a product class. Means whole cannot exist without its parts. But part can exist independently because product can exist irrespective whether the order exists or not. Hence, here is the aggregation relationship between product and order class. And accordingly, the multiplicity is defined. Every order can contain one or many products. Hence, multiplicity at order end is 1 to many. That is 1 dot dot star. And every product can be a part of one order or many order or none of the order. It's possible. There is a product on which till now there is no order is placed. Hence, multiplicity at product end is 0 to many. That is 0 dot dot star. Now, order class is associated with payment class. It is obvious because unless customer pays, company will not deliver the product. Hence, every order class has one payment method associated. So, association between order and payment class is 1 to 1. Now, every payment class uses either credit card or PayPal, for example, for capturing the payment. So, relationship between payment class and credit card, PayPal class is a dependency kind of relationship. Payment class is fully dependent on credit card and PayPal for processing the payment. Now coming to order status class. This is a special type of class called enumeration type of class, which define the type of order status during the life cycle of the order. This class get this special status by the use of stereotype of enumeration. Now coming to shopping cart class. Again, shopping cart contains products. So shopping cart and product class are joined with aggregation relationship. For you people understanding, on every association, I have named the type of relationship. You can ignore it in real time. This is simply for our understanding. Now coming to user class. Now here we have a different types of users you can say. First is customer who actually buys the product. Second is administrator who actually manages and maintain the application. And the third one is a guest users who didn't log in the application. They simply see the product catalog and go away. So here we can leverage the inheritance relationship and same is represented in the diagram. Now let us come to the user account class. Now every user has a user account. So one-to-one relationship exists between these classes. User account is the class which holds the details of the user. Let me refer user account as user only for our simplicity now. If you see, every user has an address and can have multiple addresses as well. But see, address can only exist if user is present in the system. If user is present, then address must be present. We have this mandatory condition in our application. So this relationship between address and user account is a composition type of relationship. Part, that is address class, cannot exist independently of the whole class. Hence, it is a composition relationship. The rest of the diagram, I feel you can now interpret easily. So this is the way the class diagram will be read and understand. One disclaimer is some of you might say, man, you missed this attribute, this operation or something. This visibility is wrong. I agree with that. I have missed a lot many things. But if you see here, my intention here was to demonstrate and make you understand the concept of class diagram, how to use it and represent it. So I kept it simple. But in real life, you can see a class diagram with lot many classes, lot many details, etc. So this is all about the class diagram in detail. If you have any questions, then feel free to message me. I will be happy to clarify them. In this session, let us try to cover some of the common mistakes people usually do during designing the class diagram. Learning from people mistakes is the fastest way to progress. So let us see the common mistakes now. First, overcomplicating the diagram, including unnecessary details such as irrelevant attributes or methods that do not contribute to the understanding of the system. For example, in a class diagram for a simple calculator application, including complex mathematical functions or unrelated operations. Then next, incorrect use of relationship. Using the wrong type of relationship between classes, such as using a composition relationship when an aggregation relationship should be used, or vice versa. For example, in a class diagram for a car dealership system, using a composition relationship between a car and a wheel instead of aggregation relationship. Third is not considering the relationship between the classes. Neglecting to consider the relationship between classes such as association, inheritance, aggregation can result in an incomplete, inaccurate representation of a system. For example, in a class diagram for an e-commerce website, failing to include association relationship between customer and their addresses. The next mistake is incorrect cardinality. Incorrectly describing the number of objects that participate in a relationship. For example, in a class diagram for a restaurant ordering system, incorrectly representing the cardinality of a relationship between a user and their orders, leading to confusion about the number of orders customer can place. Then next, focusing too much on implementation detail, including implementation specific details that are not relevant to the overall design of the system. For example, in a class diagram for a banking system, including details such as database schemas and programming language syntax in class diagram. Then next, inconsistent naming conventions, using different naming convention for classes, attributes or methods, leading to confusion and difficulty in understanding the diagram. For example, in a class diagram for a fitness app, using different naming convention for different types of exercises such as cardio versus aerobic. Here, to make it consistent, naming conventions we can use like cardio exercise, aerobic exercise, strength training exercise, etc. So this is all about the common mistakes which people usually do during designing the class diagram. In this session, we are going to see the another UML structural diagram called object diagram. Object diagram are closely related to class diagram as they are derived from them. Object diagrams provide a snapshot of a class diagram at a particular moment in time by representing an instance of that class diagram. While both class diagram and object diagram represent the static view of a system, object diagram provide a more specific and concrete view by displaying the active object and their relationship at a given moment. Let me repeat. Object diagram help us to represent the active object and their relationship at a given moment. To give you real life analogy to understand UML object diagram, then consider a running train. If you take a snapshot of a running train, then you will see the exact geographical location, the number of passengers on board, and other related information. Similarly, object diagram gives us a snapshot of a software system at a given moment that will show us the active objects and their relationship. Object diagrams can also include data values of an object and therefore are also known as the instance diagram. The primary difference between class diagram and an object diagram is that a class diagram represents an abstract model consisting of classes and their relationship, while an object diagram represents a concrete instance at a particular moment. The fundamentals of object diagram remains the same as of class diagram. Only thing which is different is a class instance with data. The object in the object diagram is represented like this. It is very much similar structure as of a class. Few benefits of using object diagrams are: first one is visualization. The object diagram helps in visually understanding the structure and relationship of objects in a system, making it easier to understand their behavior and interaction. Second is communication. The object diagram facilitates communication among stakeholders by providing a clear representation of objects and their relationship in the system. Third is testing. The object diagrams can be used as a reference for testing the system, providing a clear picture of objects and their relationship to design and execute test cases. Fourth is about design. The object diagram helps in designing the system by providing a clear understanding of the objects and their relationship, which can be used to design solutions that meets the system requirement. And the final one is documentation. The object diagrams can be used as a documentation of the system, providing a visual representation of objects and their relationship that makes it easier to understand the system structure and behavior. So this is all about the object diagrams in UML. In the upcoming session, we will try to understand the sample object diagram in detail. Welcome to this session. In this session, we will see the real-life object diagram of online shopping application. We have seen till now that object diagrams provide a snapshot of a class diagram at a particular moment in time. By representing an instance of that class diagram, it will show the object relationship at a given moment of time. Now, let us have a look at the object diagram. Consider a moment where order is placed by the user and we have clicked the snapshot. What we will see all the objects which are active at that moment and how they are related to each other. We can represent this in the form of object diagram like this. All the rectangle shaped structure are the objects and arrows and lines shows the link between them. Let us start with the order object. Order object will have attributes like order ID, order date, shipping address, the payment details, order status, products, etc. with their real-time values. Now you can see product object is linked to order object because order objects contains the product and product object are also linked to shopping cart object since the shopping cart also contains the product object. Every object has its values defined in the object diagram. I feel this diagram is simple to understand since we have already gone through the class diagram. You can go through it and try to understand it. One thing is we have seen payment class is depends on credit card class or PayPal class in our class diagram. But in this object diagram, we have only object of credit card because user has given credit card and at that time only one payment method can be given. Hence, we can see only credit card object in this object diagram. Similarly, for inheritance relationship, you can see single child because at a time only single child involved. Hence, here in our case, we are seeing the customer type of object only. Few important things are object diagram is similar to class diagram, but the focus is on the objects and how they are associated. However, there is not much focus on the relationship like representing aggregation, composition, etc. Object diagram is very straightforward. I think we have covered all the important things here. Hence, I don't want to waste more time in explaining it. You can go through it. In case any questions, feel free to message me. I will be more than happy to clarify all your doubts. In this session, let us try to learn from the common mistakes which people do during designing the object diagram. First, confusing classes with objects. It's important to remember that classes are the blueprint or template for object, while objects are the instances of a class. In an object diagram, you should be representing objects, not classes. For example, in an object diagram representing a school, using a class student instead of creating an individual object for each student, such as John Smith or Tracy Lee. Next mistake is including unnecessary objects. Object diagram should only include objects that are relevant to the specific scenario being represented. Including unnecessary objects can make the diagram cluttered and difficult to understand. For instance, in an object diagram representing a bank, including an object for office supplies that are not relevant to the scenario being represented. Instead, the diagram should only include the objects that are necessary for a specific scenario, such as customer, account, and bank teller. Then next, not labeling objects. Each object in an object diagram should be clearly labeled with its name and type. This helps to avoid confusion and ensures that everyone who is viewing the diagram is on the same page. For example, in an object diagram representing a hospital, failing to label each object with its corresponding name and type, such as patient John Doe or Dr. Sarah Lee. The next common mistake is failing to show object relationship. Object diagrams are all about showing how objects interact with one another. It's important to clearly represent this relationship in diagram so that viewers can understand how the objects are working together. For example, in an object diagram representing an e-commerce website, not clearly showing the relationship between the customer object and the order object. Next one is overcomplicating the diagram. Object diagram should be simple and easy to understand. If your diagram is too complex, it can be difficult for viewers to follow and comprehend. So this is all about the common mistakes which people usually do during drawing object diagram. In this session, we are going to see another UML structural diagram called component diagram. We have seen class diagram is a static representation of the code of our application, and it is a blueprint of code or very near view of the code. Similarly, component diagram is a type of structural diagram which represents a static implementation view of the system. It helps us to understand the main component of the system and its relationship between them. It is used to represent the structure of the system at a high level. Now you will ask, how much high level? So the answer is, it is just higher than the class level. You can take it as high as you can. To give you a real life analogy, let us consider a car example. A car can be decomposed into various components such as engine, transmission, wheels, brakes, steering, and so on. Each of these components can be further decomposed into smaller components. For example, an engine can be decomposed into a cylinder, head, piston, crankshaft, etc. Similarly, a wheel can be decomposed into a rim, tire, and hub, etc. A UML component diagram can be used to represent the relationship between these components. For example, the engine components may depend on the fuel system component, and the transmission component may depend on the engine component. The brakes may be connected to the wheels and controlled by the driver through the steering system. All these relationships can be shown in the component diagram. So you can say each component can contain many classes or subcomponents internally, and in plain term, you can say it is a one level up view of the class diagram or individual component. If I want to give you a simple formula what component diagram majorly contains, then it will look like this. Component diagram equal to components plus interfaces plus relationships plus ports. If till now this much is very clear to you, then let us understand the basic concepts and notations of component diagram in detail. First is component. As car can have different components, the software system will have components. Components will be represented like this. Over internet, you can see 2-3 versions of representing component, and that is fine. Now, components are related to each other for its functioning, right? So they are related via interfaces. In UML component diagram, an interface represents a set of operations or services that a component offers to its clients. It defines the contract between the component and its clients, specifying what the component does and how it can be used. A real-life analogy for this would be a restaurant. Think of a restaurant as a component and the customers as a client. The menu can be considered as an interface. The menu specifies what the restaurant offers, how it can be ordered, and what customer can expect in terms of food and services. Just like how the menu defines the contract between the restaurant and its customer, the interface in UML component diagram defines the contract between the component and its client. Clients can interact with the component only through its defined interface, and the component is obligated to provide the services and behavior specified in the interface. If the restaurant were to change its menu, it would be similar to component changing its interface. Clients who were familiar with the old menu might be confused or frustrated by the change, and the restaurant will need to communicate the change effectively to its customer. Similarly, if a component were to change its interface, the client will need to be notified and the changes will need to be managed carefully to avoid disruption. So coming to software world, interface represents the set of operations or services that the component or system provide to its clients or other components without exposing the implementation detail of those operations or services. It defines the contract between the component or system and its client. Now coming to notations, there is a one component who will provide the interface and other who requires that interface, right? So two terminologies used, that is provided interface and required interface. A full circle represents an interface created or provided by the component, and a semicircle represents an interface used or required by the component to interact with the other component or system. The semicircle is typically drawn on the edge of the component symbol adjacent to the interface it represents, and it indicates that component depends on that interface to function properly. Together, the full circle and the semicircle symbol provide a visual representation of the interfaces associated with the component and its interactions with the other component or system in the overall system architecture. Now moving to the next concept of component diagram, that is dependency. There are cases where one component depends on another component for its functioning. For example, payment component depends on user authentication component because it needs to verify the user's identity before processing a payment. This dependency can be represented by an arrow pointing from the payment component to the user authentication component. And the next very important concept is of port. In UML component diagram, a port represents a point of interaction between a component and its environment. It can be seen as a connection point through which a component can send or receive messages. Ports are represented using a square along the edge of the system or a component. A port is often used to help expose required or provided interface of a component. A real-life analogy for a port in a UML component diagram could be a port on the computer. Just as a computer port is a point of interaction between the computer and its environment, a port in a component diagram is a point of interaction between the component and its environment. For example, a USB port on a computer allows the computer to interact with the external devices such as mouse, keyboard, etc. Similarly, a port on UML component diagram can allow a component to interact with other component, services or systems in the overall system architecture. So this is all about the basic fundamentals of a component diagram. Now, component diagram is extensively used during the design and architecture of a system for below reasons. The first one is to model the component of the system. This will visually represent which all component our application is currently having. Then second is to model the schemas of database. That will visually represent the database level details like which all table we have and how they are related with each other. Third is to model the applications of an application. If ours is an application which is composed of many other smaller applications, then how they are related to each other, it is represented by component diagram. And the fourth is to model the system source code. You can use component diagram to visually represent how is your source code is structured. So this is all about the UML component diagram. Welcome to this session of component diagram. In this session, we are going through the real life component diagram and we will try to understand it in more details. We have seen in the previous sessions that component diagram is a structural diagram which represents the static implementation view of system. Via this diagram, you will get a clarity on the main components of the system and relationship between them. We have also seen component diagram is a high level view of the system. Now let us have a look at the component diagram for the online shopping application. You can see the components, interfaces, relationship, ports and connector everywhere because these all things together make the component diagram. Let us start from the left side where we have an interface. Now this is an interface used by the user to interact with the application frontend. Then we have a component called shopping app frontend. It is a bigger component. Hence I have stereotyped it with the subsystem. It is a subsystem in the whole system. Now this shopping app frontend contains the frontend components like UI, services, state management components, etc. And you can see we have options to represent the artifacts or content of the component. Now, for example, in the UI, we have a HTML, CSS, TypeScript code. Similar way, you can represent the artifact wherever you think it is required. Now, obviously, this front-end won't work unless a optimized backend. So, we have another big component called shopping app backend. I have again stereotyped it with the label subsystem because it is again a subsystem within the whole system. One thing to notice here is front-end and backend are connected with the required and provided interface. Means backend provide the interface means backend provides a set of methods or APIs or services which front-end use or consume for making front-end functionality work. It is represented like this and this communication happens via defined ports at both the sides. Hence you are seeing the small square at the border of each subsystem. Now coming back to shopping app backend subsystem. This subsystem contains business layer which is a topmost layer in our design architecture. This business layer connects with the relevant product service, shipping service and payment service to get its task done. Hence, you can see necessary ports and required and provided interfaces between these components. Now, this shipping service, product service, payment service needs the help of the external system to fulfill its task. Hence, we can say they are dependent on the external systems for its functioning. Hence, backend subsystem is connected with the external system via relevant ports. Product service needs the support of Elasticsearch system to get the results of the products for the user queries. Hence, it is consuming the Elasticsearch interface. It is a situation of provided and required interface. This type of situation can be represented like this in the component diagram. This dotted arrow is for the dependency. So this is all about the component diagram for the online shopping application. In case you have any questions or doubts in this diagram, feel free to message me. I will be more than happy to address them as soon as possible. Now it's time to see some of the common mistakes which people do during drawing the component diagram. First one is including too much details. Including too much detail can make the diagram overly complex and difficult to read. It is important to keep diagrams simple and focused on the essential components and their relationships. For example, including every single component of an online shopping application in the component diagram, including those that are not critical to the overall architecture. Next is failing to identify interfaces. Another mistake is to omit the interfaces between components. Interfaces are important because they define the contract between the components, and without them it can be difficult to understand how the components interact. For example, not showing the interface between the client component and the server component, which can make it difficult to understand how the two components interact. Next is not including dependencies. Dependencies between components are also important to be included in the diagram. This helps to show which component depends on others, and can help identify potential issues if a component is changed or removed. For example, not showing that a component depends on a specific library or framework, which can lead to issue if that library or framework is changed or removed. Next one is not properly grouping related components. Failing to group related components together can make it difficult to understand the architecture. For example, showing all components in one flat hierarchy instead of grouping them based on functionality or layer, making it hard to understand the overall architecture. Then next, including irrelevant component. Including components that are not relevant to the architecture can make the diagram more complex than it needs to be. For example, including a component that are not used in the architecture but just clutter the diagram, making it harder to understand the core components. And the final one is not using consistent notations. It is important to use consistent notations throughout the diagram. Inconsistent notations can lead to confusion and make it difficult to understand the relationship between components. For example, using different shapes or colors for components in different parts of the diagram, leading to confusion and difficulty in understanding the relationship between the components. So this is all about the common mistakes which people usually do during designing the component diagram.